Welcome along to another PMAC data engineering stuff video, just focusing in on those niche bits and pieces that are not quite so easy to get from online docs or blogs. I'm actually going to follow on from the previous video with this one. We're going to talk a bit about change data capture, or CDC, and into the detail about how easy it is to do that with Databricks. But first off, I'm going to cover off a quick intro on what exactly is CDC. So here's a little slide deck I threw together. Standard database setup, you have an application and that is doing whatever it is you need it to do. And that's pumping data into your source database. That could be lots of new records, insertions, lots of updates to existing records, could be some deletions in there. Those are the main things that you normally have happen. Even with a merge, it's update, insert, delete, all at the same time. The next step is we have a CDC output. Now, there are lots of different ways of doing this. Some of this could be out of the box with the database. Some of this you could get a third-party tool to do. Some of this maybe some specialist thing, a bit like the GuideWire one we talked about in the other video. But the point is you get an output and you get insert, updates, and delete records coming out in the output. Separate row for each one of those. So every time you insert a record, there's a new row. Every time you update a record, there's an update to that row. So you get a new row for that. And every time you delete, there's another entry to say this row has been deleted. Now that output could be going out to a table. That could be going out to a CSV file. It could be going out to a Parquet file. It just depends on what that source system is and what that setup is for that CDC. The point is it will be streamed. We're then going to do some transformation on that, and we would typically use Databricks for it, and we will change that insert, update, and delete into one or two things. Now, if you're familiar with slowly changing dimensions, or SCD, there are two main types that we worry about. There are lots of other types, but the two main ones that most data engineers care about are type 1 and type 2. And type 1 is pretty much a replica of what you have in that source database. As you get those updates, inserts, deletes, they will flow through. Type 2 is you would get a from date, until date, current flag, that sort of thing. The idea being you can then replicate exactly what that data looked like at any point in time. And if you speak to any data scientists that want to replicate any experiments at a set point in time, that's exactly what they will need. Let's just run through how that works in practice. So we have our inserts, updates, and deletes on the screen. We also have what it would look like in a type 1 SCD table and a type 2 SCD table. So let's go ahead. We'll insert a row, ID number 1. So in our type 1 SCD, we have ID 1 as a record. In our type 2 SCD, we have ID 1, but we also have a start at or from date or something along those lines. This one being a timestamp, so we got this at 1 a.m. So ID 1 starts at 1 a.m. Now, many SCD tables, you will have an until date, and that will be something like the 31st of December, 2999 or something. Other ones may leave it null and blank. For the purposes of this, we'll just leave it null and blank. We'll do another insert, ID number 2. And again, this is at 2 a.m. So our type 1 SCD table now has 2 records, ID 1 and ID 2. And our type 2 SCD table also has 2 records, and ID 2 starts at 2 a.m. So if you want to know the state of the database between 1 and 2, you've then got the data there to be able to work that one out. We'll then do a quick update on ID 1, and this was at 3 o'clock. So we have in type 1 SCD, that will just go through as a straight update. So ID 1 will then be the latest version of that ID 1 record. But in our type 2 SCD table, we're going to end our original ID 1 and we'll end that at 3 a.m. because that's when it changed. And we have a new entry, a new row for ID 1 starting at 3 a.m. We can then do another insert. This is ID 3. Again, straightforward, type 1 SCD, we now have 3 records. Type 2 SCD, we have ID 3 starting at 4 a.m. So again, using this logic, you can work out the state of the data at any point between 1 and 4 a.m. We'll then do an update on ID2, same sort of logic. this was at 5 a.m. So we then end our original ID2 record on the SCD2 at 5 a.m. and insert a new record starting at 5 a.m. As we see on the end there. Again, our type 1 SCD is just an update on those records. But what happens if we delete? Well, we're going to delete ID1. So you can see from our type 1 SCD table, that is now gone. It's not there anymore. But we can't replicate any point in time on that. This is just the latest state of the data. Sometimes that's all you care about. For our type 2 SCD, we will put end date of that row at 6 a.m. We don't insert a new record to say this has been deleted. We just say this is ended at 6 a.m. And that's it. So if you look at all the active records, i.e. the ones without an end at, we have ID3 and ID2, which is the same as what we have in our type 1 SCD. And then we can update ID3. So same sort of thing. ID3 gets updated in type 1 SCD. And then in your type 2 SCD, end at 7 a.m., we have a new entry for ID3 starting at 7 a.m. And then we can do an insert. You get the idea on how this sort of thing flows. So ID4, new entry, appears in type 1 SCD, and then type 2 SCD, have a start at 8 a.m. So if you have no need to work out exactly what the state of that data is at any particular point in time, then you're better off with a type 1 SCD. You might just want to know what the latest state of that data is. And you might find that where you would have maybe a lookup table, something which doesn't get updated that regularly, something that where you're not going to need to replicate it or work it out at any point in time. Type 2 SCD, particularly important for some data science experiments where you want to replicate at an exact point of time to replicate exactly what that experiment was. But how do you do this in practice? Well, shifting over to Databricks, and we will start off, well, I've done this on the free version. If you don't know what the free version is, just do a search for the Databricks free edition. And you can get all the features and functions and things that you want from a normal Databricks environment and just be able to run these sorts of experiments. So that's exactly what I've done here. And just to show you what my table looks like, I've just created a customer table completely full of some random bits and pieces. So imagine this is our CDC feed coming in. We have a bunch of customer IDs. We have some first names and last names, which you can see are completely random gobbledygook. We have some address line ones. Well, at least we have a number in the word street or avenue. But otherwise, it is just all garbage. And some random postcodes and some random telephone numbers. And some completely made up email addresses, which is literally just the first name and the surname from over here at example.com. Nothing too exciting. Now, there are three really important columns in this table. The first one is the primary key, and the primary key in this one is, of course, that ID column. So that is really, really important. The other two are the change type and the update date time. So it depends on your CDC tool as to exactly what these are called. In my example table, I've kept this nice and simple. All of my inserts and updates and deletes, I literally just have the word insert, update, and delete, and they appear in my change type column. So where we had the insert, updates, and deletes on our previous PowerPoint, we get that sort of information there. And we also have when it happened. This is important to know what sequence things happened. Otherwise, you might end up with an update before you've even inserted the record. You might have deleted the record before you've inserted it. So both of these columns are really, really important. They have no relevance outside of the CDC process. You might want to know, you might not want to know. But this sort of information is then used, the update date time will be used to drive that slowly changing dimension date. Let's look at one record in particular. We'll look at cust 004 because I know this has two entries. This might just explain it a little bit more about what order and what sequence this runs in. So there we go. So we've got two records come through, two different addresses on this one and two different telephone numbers, which isn't unusual. That'll be if a customer moves house and they need to update their information. So we have our original insert there, which happened at 7:33. And then we have our update, which happened at 18:36. So what we would expect to see in our type 1 table is just the data equivalent to that. In a type 2, we should see both. So how does this work with a CDC pipeline in Databricks? Well, if we hop on over to the code, this is what our code looks like. Really, really simple. So breaking this down into the different sections. First off, we have our create or refresh streaming table. And this is just the name of the table we're going to call this. We create a flow, and this is the name of our flow. And this is what's going to populate that table. So in this case, we're going to call this flow SCD2 flow. And it's just going to push data into our SCD2 table. We're going to stream this in from our CDC table. So that is that table we were just looking at with all our records in. Then you have to tell it what the primary keys are. In this case, we only have the one primary key, which is our ID column, which makes life nice and easy. Apply as delete when. It's taken an assumption that any inserts or updates are new entries, and it will just check, see whether or not that ID already exists. But for a case of delete, it needs to know, how do I know when to delete it? In this case, we have our change type labeled up as delete. And if it finds that, it knows that that's a deletion entry. And also we have sequence by. So sequence by is our update date times. This tells us what sequence to process all that data in. And if you remember, this relates to the three key columns that I mentioned earlier. So we have our ID, our change type, our update date time. We can take all the columns, or we can take some columns out. For me, I don't think change type or update date time is particularly interesting in this concept outside of that. And then stored as SCD type 2, or you could put type 1 in there. And it's as simple as that. You just set that up for each one of the tables and it will process that for you. You don't have to think about complicated merge statements with complicated setups. And it is as simple as that. So we're just going to go ahead and connect into some compute, and then we will run that pipeline and generate that table. Now, because we are in Databricks 3, this starting up of the compute can take a couple of minutes or so. So we will just let that run, and I'll come back to you when it's ready. Okay, so now we have our compute. We can then go ahead. We could do a dry run, and a dry run will just validate to make sure everything is set up as it should be. And that's what we've already done here, which is why we haven't had any duration or anything happen on this streaming table. If I run this pipeline, this will then go ahead, read through. There's about 1,000 entries in that table. We'll go through and read in that data, and then should generate that table for me. And there we have 25 seconds. You might think is a long time, but the intention of this pipeline is it should be on streaming that data through and taking that data through reasonably quick. So new entries come in, they flow through the pipeline, arrive in Databricks, we process it and convert it to our CD table. So we pretty much would have this running all the time. Because we're just in a demo and also we're on Databricks 3, we're obviously not going to be running that all the time. So what we'll do is we'll take a quick look at that table. We'll do a new query. And let us just do a select start on that data. Run that through. And then what we should see come out is our CDC output. There we go. So again, it looks pretty much the same, except we have these new columns on the end. We have our start at and our end at. So if we want to look at our customer 004 again, customer 004, as we did in the other example, 0004, as we did on our other example, then there we have our two records. And we can see this one started at 7:33, ended at 18:36. So this one starts at 18:36 and ends at null. So I just want to get the record for all of the current entries. I can do where the end at is null. There we go. And I can do that for all of our entries. And that will give me the equivalent of an SCD type 1. So you could expand that further. You could add a view on top of that if you need to, and have a current flag, which would just be a simple case when end at is null, or you'd leave it at that. But that is a streaming table, and we could rerun that as many times as we need to. And it's as simple as that. Just a few lines of code, you could process through your CDC table really, really quick. Now, what if you've got hundreds or thousands of these tables? Well, in that case, I would probably say rather than do that in SQL, maybe do that in Python and use some of the Python looping functions. So that way you just list out all of the tables that you need to run the CDC process on, and you can get it to do it all in a more automated fashion. Again, you could do that maybe in a dozen or so lines of script, but again, it's all done through Databricks Declarative Pipelines. It's nice and easy. I hope you enjoyed that. Short and sweet. I'm here if you need to ask me any questions. Otherwise, subscribe and like.